So in the last video, we were looking at vertical asymptotes, which meant our function was getting bigger and bigger and bigger forever, so our limit was equal to infinity. Now we're going to see what happens as x is approaching infinity. So what happens now as we get way, way, way out here? And that's called a horizontal asymptote. So a line is a horizontal asymptote if we're looking at the limit as x gets really big and we get a number, like a constant, then that is our horizontal asymptote. And this will come up on the AP test. So again, it's going to be the limit as x approaches plus or minus infinity. So again, it's just how high is this function getting to as we get infinitely big or small. So as we get way, way, way out here to the right or way, way, way out here to the left, how high or low does this guy get? A function can cross a horizontal asymptote. So if I have a horizontal asymptote, it is possible that I have something that would look like that. It's allowed to cross that and still be a function. However, it is not allowed to cross a vertical asymptote. And the reason is, if it did, now it's not a function because of that vertical line test. So it is allowed to cross a horizontal asymptote. So here's your theorem. This one's kind of hard to understand, so I'm going to try to give you an explanation. But if r is some positive exponent, c is just a number, if I think of it as plugging infinity in, what I end up with is some number over infinity. And so if we think about looking at, like, let's say a pizza, if I had like 1 divided by infinity, we can think of taking one pizza, and splitting it up, because that's what division is. We're going to split it up into pieces. So if I split it up into 2 pieces, each piece got smaller. If I split it up into 4 pieces, each piece is smaller. Because I'm approaching infinity, I want to split this pizza up into as many pieces as I possibly can. And what happens is each piece is getting so small and so small the closer I get to infinity that it's approaching 0. So if I have any number over 0, the limit equals 0. So in my example here, I'm really taking the limit of each piece. I'm really taking the limit of 5 minus the limit of 2 over x squared. And remember, when we take the limit of a constant, it's still approaching that constant. And here, if I try to think of this as direct substitution, I get 2 over infinity. So again, think of this as like 2 pizzas now, split into a ton of pieces. Each piece is getting so small it's approaching 0. So my final answer is just 5. Okay, indeterminate form is infinity over infinity. One way to deal with this is to divide the numerator and denominator by the highest power of x in the denominator. Basically, our denominator is our problem. That's the problem. That creates discontinuities, it creates vertical asymptotes, so we want to get rid of any variable that's in the denominator. And one way to do that is to divide it by itself. However, in a fraction, we need to do that to the top and the bottom. So if I decide that I want to divide everything in the bottom by x, then I also need to do the same thing in the numerator. So if I divide every single thing by x, I'm creating an equivalent equation. And so I'll get 2 minus 1 over x all over 1 plus 1 over x. And now I can try direct substitution. If I plug infinity in, I'll get 2 minus 1 over infinity all over 1 plus 1 over infinity. And remember, one pizza divided into a lot of pieces goes towards 0. So this is really the same as 2 minus 0 over 1 plus 0 or 2. You may remember the 3 rules from pre-calculus. These 3 rules are acceptable to use. If you mess them up, there is no partial credit awarded because you have shown no work. I do find that a lot of students mess these up. I personally do not have them memorized. I don't use them. I would prefer to think about it. The other thing is these only work when x is approaching infinity, and a lot of students try to use these on every question. So if you were to use these, we would look at the highest degree in the numerator and denominator. So here we have a higher degree in the denominator, and it says the degree of the numerator is less. We're going to use rule number 1 here, and you don't have to write that down, but the numerator is less than the degree of the denominator, then the limit is 0. So that just means the entire value of the limit is 0. And we could also use the technique we used on the previous page. We know that the denominator is a problem, so we want to get rid of all of these. So we're going to divide everything by x cubed. When we do that, our first term results in 3 over x. Our second term results in 4 over x squared. And our last term is 3 over x cubed. In the denominator, we get 1 plus 1 over x squared plus 14 over x cubed. If we then try direct substitution with negative infinity, even though that's negative, we can still use the same idea as our pizza. Each one of these is approaching 0. So in the numerator we get 0, and in the denominator we get 1 plus 0, which results in 0. So it's up to you whether or not you want to use the 3 rules. If we use the 3 rules here on example 3, sorry I skipped number 2, the degree is higher in the numerator, so we're going to use rule 3 here. The limit does not exist. Now the problem with using these rules is this is not sufficient as an answer, okay? We have to see if it approaches without that. So we would need to see, does it go towards positive infinity, negative infinity, or do we just have to say does not exist because it doesn't approach one or the other? So that would require more investigation. So just be careful of using those 3 rules. So here's our summary. Again, always try direct substitution first. If that doesn't work, try a factor. Some other techniques are to multiply by the conjugate. They are not going to ask you to do that on the AP test. You could look at a graph or table if you have one. If the limit has x approaching infinity, then you can use the 3 rules. You can divide by the highest power of x in the denominator, which is a technique we looked at in the video. Or we can use L'Hopital's rule, which is something we're going to learn about later in chapter 3. And if nothing else works, then it's possible the limit does not exist.